My name is Shashank, as very nicely introduced me. I have largely been a part of the deep water story in India since it began from the very concept in shallow and deep water. And I've been asking a lot of questions to the experts back in North Sea or Gulf of Mexico. So there's a lot of stuff that possibly I'd like to share with the people on what the complexities are like. So let me see if I can quickly. That's about me. That's, I'm a petroleum engineer from ISM Dhanbad. Did my MBA, got back into the oil industry, couldn't stay away. And I'll just break it down in terms of the deep water complexity. What they talk about complex things is break it down into simpler things which are easier to swallow, right? So how do you eat an elephant? You eat it in small bites that you can actually swallow. So deep water is like that. So I'm trying to break it down in this 15 minutes into equipment, supply, deep water project, and complexity, right? That's largely my topic as well. And, you know, uh, like all things complicated, I'm breaking it down. So as Sengupta sir very nicely said, it's barely, it's less than 50-year-old, the concept of deep water. And why deep water? This is something which I kept asking my guys. Yeah, some places you say it's 200 meters deep water, some places 300 meters is deep water. What exactly is causing this definition of deep water? And I'll talk about it. It's an interesting story. But before that, I would start from the bottom with what Richard Branson said, saying that complexity is your enemy. Any fool can make something complicated. It's hard to keep things simple, right? And I love to keep things simple. And trust me, deep water, keeping it simple is really, really difficult. So to try and explain someone simply what it is I tried connecting high pressure, complicated and unpredictable reservoirs to heavy metal 300 plus meters below the sea on muddy, rocky beds operated through subsea internet and very high voltage, which is like 600 volts plus, producing hydrocarbons without leaks through complicated series of equipment installed in marine and human habitat with 100% QHSE compliance. What I forgot is for 20 years, right, or more. Right? Some places, even in ONGC right now, it's doing for more than 30 years. So keeping this simple is a little bit of a challenge, but I'll try and keep as close to the complexity as possible. So what makes it really complicated? Let me start with the deep water thing, right? So the very fact that extreme depth, you know, we know things increase with depth, which is the column of water which is above the equipment that you're putting on the seabed. And the pressure gradient increases. So you have what, zero point 0.5 psi per feet. You're talking about even 300 meters. Then you're talking about, it is around 10,000 feet. So you're talking about around 5,000 psi, which is on it, collapse pressure. You don't want things to collapse. What do you do when you don't want things to collapse? It's metal. You'll make it thicker. You will make it heavier. Moment you make something thicker and heavier, heavier means you're handling it from the surface. So someone is hanging it from a vessel somewhere, and that's Sundar and McDermott or some installation contractor, and they have to make their vessel bigger, right? Not just that, because it's on the bottom of the sea. So when depth increases, what happens is it's on the seabed. So when you try to operate a valve, because that is essentially what you're doing when you're producing stuff, right? You have your trees which have their valves, or you have your manifolds which have their valves. How does a valve operate? As in, eventually you have to turn the valve open. Unlike onshore, in deep water, nobody can go and actually turn the wheel of a valve to open it. And you can't simply operate it by electric controls. It's electro-hydraulic. Electric controls have their own share of problems in reliability. So electro-hydraulic controls it is, which means there's an actuator which is very big and you have to move it, right? So actuator, when it comes out, it displaces water and 300 meters of water above it, or 500 or 1,000 or 1,500 meters of water above it, which is applying pressure on it. And you can't design a different actuator for every field that you operate in. So many of the OEMs like us, in the past, when I say us, which is Vetco or Schlumberger, which is Cameroon, or FMC, we drew a line in the sand and said 300 meters tak we'll do an actuator of this size, right? And beyond 300, we'll do a big actuator which can operate up to 1,500 meters of water depth. So wherever we drew the line in the sand, the actuator gone from smaller to bigger. Now what happens? The actuator doesn't operate by itself. It's sitting in a house, a body, a master valve block, as you would call it, which is the main tree. So the tree becomes bigger and it becomes more heavy and it becomes more expensive. So that's where this confusion between 200 ka hai ki 500 ka. And even now operators, as in someone like us, we cross over at 800 meters. When I say Baker Hughes crosses over at 800 meters, Aker does up to 1,500 meters, a small one, then something bigger. FMC does something different. They have different water depths and they keep. So, That's the complexity. Bigger, heavier, and that's why a shallower well or a shallower water well is smaller, easier to handle. It's a different animal. The moment you talk deep water, it starts becoming a different animal. Then the reservoir themselves are unpredictable. Now, the client will come back and say, there's sand, I need to monitor pressure, I need to do this, that. So what do you do? As in, I'm giving a very simple analogy. When you come to this auditorium and you're designing it, imagine this is a flat piece of land, you're designing it, and the guy who's going to use it says, मेरे को यहाँ पे 25 light चाहिए, I need a fan there, and I need a spotlight from the bottom, I need connections for the television. In your home electrician, you know what he will say. All of that, you want them to be operated with the same switch? No, I want a separate switch for all the lights. So he said, okay, so I'll need to put 30 switches here, right? So I'll put 30 switches, each switch turns on, turns off some function in this auditorium. That's exactly what happens subsea, right? So when you want to bring in a lot of functionalities from 700 meters below the water to 50 kilometers away onshore and want to operate one valve, you need to have a separate line to do that. So you have separate functionality. And by the way, it is being operated by electricity, which is more than 600 volts, as delivered at that point. So you have to pump very high electricity from somewhere onshore. And you have to pump fluid, which is operating it, electrohydraulics. And then there is communications, right? So internet on the subsea, pretty much, which is operating on a fiber optic network. It gets as complicated as you think it can get. Imagine trying to operate your switches in your house even when one drop of water goes in it. And here there is 700 meters of water pressing down on electrohydraulic controls sitting on the surface of the sea for the next 20 years, and you're still operating it. And when you design it, you're designing it for 25 switches because the 25 light on karna hai, 4 fan on karna hai. Now once you've designed everything and you've done the concealed piping and all of that is done, suddenly the owner says, "Arey yaar, main to yahan pe bada wala ek light bhul hi gaya. So I need 2 more spotlights there and I want you to put that in." Can you do that? Without breaking open everything and doing the concealing again, you can't. That is what makes deep water complicated, right? So if your design is not frozen, or if your electricity code regulations change, saying that lal nahi, for live wire from now on you need to use burgundy. So what do? You pull out everything that you've already manufactured and installed and put something new in there, right? So there's a bunch of things. And then the most interesting part about deep water from a client's perspective is, unlike an onshore field where you go in and you do your capex and in a year or two, you possibly recover some money and you get some oil. In a deep water field, you will be lucky if you get your first dollar in cash in 5 years' time, 6 years' time possibly, right? You can cut down the cycle, but you possibly will find it very difficult to bring back the cash, the first dollar, not the entire payback. How much would your payback be? As in, you'll possibly start recovering your money in the 5th or 6th year. So upfront, you're spending billions of dollars, and then you're getting money back in small tranches with the complexity and unpredictability of the reservoir many years later. So what do you do as an operator? You want to transfer the risk back to your supply chain. What happens to the supply chain? Well, if your field is successful, they're successful. If your field is not successful, then they start breaking and sinking. So you don't have a supply chain which can do these complex things. So you have a very limited number of people who you're left to play with. 2 FPSO vendors who will show up, maybe 1 or 2 SPS suppliers, maybe 1 or 2 SURF contractors. Now, they too have the same years of cash burn before they start making money. So anyone in this chain does not make money, the entire chain breaks down. That is what the complexity is. So your entire supply chain is so constrained that they can possibly cater to maybe 200 units of, subsea wells or trees in a year. If your demand goes to 500, can't do anything about it. You'll only get it much later. So if I move to the, I'll not get into the details of the complexity here, but I'll get into some simpler things, right? So talking about the physics, I was talking about the physics of this stuff. Let me also talk about the, the physics of the collapse pressure, the bending moment. The bending moment, from a drilling perspective, and possibly you realize this is something which is common in shallow and deep water. What is a bending moment? Very simple, right? When you put something which is fixed, and then you connect it to something which is moving, the bigger is the distance or the length, the smaller is the angle, more fatigue or the more bending moment or the more snapping load you're putting on the fixed object. Well, your wellhead is fixed, unfortunately. So is the tree on top. Now, if your vessel on top keeps shaking around, or if the weather is too bad, what will it do? It will eventually end up snapping it, right? If there's an anchor which is being dragged and it runs into, unfortunately, a pipeline or an umbilical or a flexible pipe, it drags it, well, it's not flexible enough to handle that. It'll snap. So That is the physics challenges there, right? You want flexible stuff, but not too flexible, because if it's too flexible, it'll possibly collapse. Then there is a mechanics challenge, right? We talked about hydraulics, electrohydraulics, how the actuators need to actually move. There's a metallurgical challenge. So if you want to do really, really deep water, you want an FPSO in, let's say, 3,000 meters or 2,500 meters, you need to have a pipe which comes all the way from the seabed, or rather the mean sea level, down to the seabed from where you are actually going to produce. Now imagine a 2.5 kilometer pipe which is suspended, flexible pipe which is suspended from an FPSO, the amount of collapse pressure on the pipe at the bottom, right? It can simply, it will snap the turret of the vessel from where it's hanging, right? So what do you do? As in, you make it lighter, you make it composite, then, it possibly becomes very expensive. Then you say, my field economics don't justify it. So you have to look at the metallurgical challenges. If you use simple metal, you have a problem. If you're producing something corrosive and it starts corroding the inside of your pipeline, you have a challenge because you want to do, Inconel or some kind of cladding. It changes the mechanical properties. So the selection of metallurgy, the selection of mechanics, and then no touch and feel. That's the most interesting part of deep water, right? Even shallow water, you still have the ability to go and mobilize. Bahut shallow water, then you can send a diver. But shallow water, you can at least send ROVs. Now, when you send an ROV, it's expensive. You have to have a vessel with an ROV. An ROV, end of the day, is just a robot. It'll go and see something. It can't fix everything. A lot of things which you realize in your life, it doesn't sound right, it doesn't feel right, it doesn't touch right, it doesn't operate right. Subsea, you don't have that choice. Even making up a flange, you're not going to go and put studs and bolts. So when you're putting something, it has to be self-aligning, the clamping, you will use clamping systems. So you have no touch and feel, you don't want to pull it out because it's very expensive to pull it out once you put it down. It has to be right the first time and should work for the next 20 years. That is a design philosophy. And then establishing comms, as I said, establishing comms is such a difficult thing. Try setting up internet at home, right? Uska software upgrade ho jata hai. Software does not comply with the hardware. Now imagine that someone who supplied the wire is different, the router is different, the internet connection is different, and you're trying to run your TV with it, which is what you really want, and these things don't talk to each other. That's what happens subsea as well, right? Somebody is supplying one component, somebody is supplying something else, sensors are from someone else, all of them are following some codes, someone upgrades their firmware, someone doesn't upgrade their software, and you can't, fix it when it is on land or it's offshore or shallow water. In deep water, this becomes a nightmare. Even the very fact that the umbilical which is carrying all of these signals, for God forbid, for whatever reason, it wasn't handled properly, this thick, right? No, it doesn't handle properly. You have one cable which snaps, right? One hydraulic cable which snaps, or you've the subsea internet, the fiber optic cable, or whatever the copper that you're using for transmitting signals doesn't work. You're in the dark. You don't know what is going on in your field. So, the challenges of establishing comms. You can have a perfectly functional field and not know anything about what is going on there, which is happening in a few fields, deep water. And this is, despite all of that, when you look at this map, you will see in the 21st century, over half of the major oil and gas discoveries were made in deep water. Right? That is where the oil and gas is. You see, India, yesterday the DG was showing the regions have been expanded further. That's all deep water. So the no-go zone is now a go zone. There is no more no-go zone. It's not simply offshore, because offshore, to thoda der baad 50, 100, 200 meters is crossed. You're talking about deep water. All of it is deep water. All of these challenges are real, and the supply chain remains to be very small. Now, when you look at projects, there is a bias. There is a knowledge bias. There is this Dunning-Kruger effect, which all of us are possibly aware of. What happens is, we are all domain experts in some particular domain, right? Possibly in a few more domains. Oil and gas industry is fairly complicated, right? Somebody would be very good at 1, 2, 3 things, but that would make them think that they are very good at 4, 5, 6, 7, 8, 9, and 10 things as well. Which happens when you put an experienced project manager in charge of a subsea project, he would say, "Kya, maine to bahut complicated project kiya hai." But then when you get into something where there are 20,000 plus line items, and I'll show you the kind of equipment being made, one item is not tested properly, the second time over, the entire project goes on a halt, which happens very frequently, more frequently than you can ever think happens. And it puts millions of dollars on standby every single day, because your installation contractor is standing there with his entire fleet of 20 vessels, and you can do nothing because a seal on one of the particular items, which is one of the maybe 50,000 items you have installed, or one of the 50,000 subcomponents, was installed upside down, or had a corrosion or a gash before it was installed. So the entire execution matrix, this is the execution matrix that you see for a very simple project, right? You'll possibly be executing this in any typical subsea supplier in maybe 15 or 20 global locations. Each guy who is managing this project would be a domain expert of that domain. Now you need someone who's a domain expert of putting things together, which there are very few, right? So what happens here in terms of this project is the client domain expertise starts playing a major role. And I was talking about Dunning-Kruger effect. When you're very good at one thing, you start thinking you're very good at the other thing as well. So you have some clients who have a lot more experience with deep water. We saw deep water just started in 1975. It came to this part of the world maybe 10 years, 15 years back. It came to some other parts of the world in a big way after 2000. That was in the second wave, or third coming of deep water. So sometimes you have to trust the OEMs, which clients will find it difficult. So that's exactly going back to the lighting example. नहीं नहीं मेरे को ना ये एक लाइट चार लाइट राउंड चाहिए एक पांचों वाला फ्लैट चाहिए आई लव अ फ्लैट लाइट ही सेज सर जस्ट गिव मी द ल्यूमेंस द ब्राइटनेस दैट यू वांट इन द रूम व्हाई डू यू वांट टू डिस्क्राइब द काइंड ऑफ लाइट आई वुड बी यूजिंग no I want to tell you the kind of light you should use, and by the way the wire that you use, it should be pink, I don't want red. So the code says red. No I want it pink. तो client का सुनोगे किसका सुनोगे. So what happens is when the Dunning-Kruger effect plays in, right? The Dunning-Kruger effect says that your confidence and competence are inversely proportional the less you know about something, right? So when you know little about something, you feel it's very simple, I know everything. When you start knowing a little bit more about something, you start realizing, अच्छा मेरे को उतना भी नहीं आता. When you really are an expert, you'll be sitting in this conference and you'd want to listen to everyone and find out what you don't know. And that's possibly, that says all of the people here are on the Dunning-Kruger curve to the extreme right, who know that we have still got something to learn. But not everyone is like that. So you have a challenge in deep sea projects when you run into someone who thinks they know more than they do. And they screw up the project by years at times. And then there's morale and burnout. So what happens when, everybody likes instant gratification. You want something and you want the results. You want increments in this year because you worked hard. You want your rewards in this year because you worked hard. And this is purely from a personnel perspective. Or what happens in a deep water project, there's possibly going to be for the first 4 years, immense amount of screw-ups. So you'll have, you'll burn one project manager, you'll burn one engineering manager, you'll tire out another one, you'll run through possibly 4 or 5 project managers before you even get to the end of the project when you say, boss, बहुत successful project था, ये तो बड़ा अच्छा था. By that time, you've already lost those people. Some will leave the industry, some will possibly lose their jobs, never find another job. This morale and burnout, what it is doing is that, at this stage, you've got very few domain experts left in this domain because a lot of them have been burnt during the last 7-8 years of downturn because of no fault of theirs, right? So that is going to be a very big problem going forward in deep water projects, which will add to the complexity because then you'll have people on the Dunning-Kruger curve on the left who think they know, but they won't. And then that'll be a problem. Okay, so I've got 2 more slides. Should be able to hit my target. Devil is in the details. So, the only purpose of showing this slide is to show this little thing here. I don't know, the pointer doesn't go. This, right? So when you look at the amount of subsea equipment installed, you see this big tree which looks very fancy when you see it being installed. One of the flanges on the tree, this is just one of the small clamps, a connector, which onshore is just a flange, right? You have an API flange with bolts on it. One of the flanges, one of the connectors on the tree has these many subcomponents with very limited supply chain. One of these parts is not available, your project will go on standby, which it does at times, right? And just talking about one of the smallest parts, look at the control system, look at the amount of things that it looks like inside. You break it open further, you will see circuits being assembled by hand. It's all handmade, like tailor-made suits ke jaisa ye tailor-made control systems hota hai. Somebody assembles by hand. The umbilical, you see the massive umbilical that old man is trying to point to on the left of the screen. It's basically the cross-section of it looks like this, right? There's the number of functions, the number of wires which are going through that massive reel of umbilical. It just gets one small scratch during transportation and the entire functionality of a 10-kilometer umbilical is lost, right? So that complicated it is. And then supply chain, right? So typically you have less suppliers than buyers, right? How many suppliers are there? Pick any equipment in subsea, any installation contract, 3, 4, 5. There'll be more buyers than that in a single country. And there are more regions than that. So people just burn out of regions. The supplier, they say, we don't want to work in Asia, or we don't want to work in North America, or we don't want to work in Latin America or Africa. Gaya, us jagah mein wo supplier kabhi aayega hi nahi, right? So what happens is we as, now I'm on the other side. So, as service providers, you expect to be able to make money. You expect to be able to have the client talk to you. You expect him to help in your career progression, right? You expect him to, अच्छा, ये अपना है? नहीं. So this is possibly, so, you go for small items, like forging supplies, wall supplies. Yeah, small walls, big walls. You'll finally end up finding one or two people who can make 300, 400 walls in a year, or 500 walls in a year. And there are three projects going on. All of them need 500 walls. What will they do? They'll choose one. They'll choose one buyer for whom they want to work, for whom they can make money. Now, if you don't manage your supply chain well, that guy will not work on your project. So you do everything that we've talked about so far. You've done immensely well in exploration. You've done all the best concepts in field development, everything. You're waiting for that one wall to show up so that your project can be delivered 1.5 years early, right? So eventually the supply chain is so complicated in deep water because you don't have enough suppliers. People never qualified them. The role of logistics. Now try moving something which is, we've done it in India. When we tried to do the first gas on the 98/2 project, we had to hire an Antonov thrice, right? Because there were some things, you can't book a ship and expect it to show up 1.5 months later when you want to produce gas in 6 months or 8 months or 9 months, right? So you hire an Antonov, which is the biggest thing which can carry something, by air, and then you try and get it somewhere. Even the simple role of sending stuff by containers or sending stuff on a vessel which travels all across the world in 2 months' time. Instead of that, if you could get a fast boat which can travel in 1 month time, you're saving time on the project. It's, and people underestimate the role of logistics. They do not hire very good logistics managers in deep water project. Client side, you'll possibly not even find a logistics manager who is engaged. Even on the supplier side, some of them don't even have logistics managers. So that is something which is very complicated. Disruptive events we all have, we know about. Need for expertise and talent. So now the interesting thing we do, especially in India, in a lot of other countries is also, we measure expertise in number of years. अच्छा उसने 10 साल काम किया तो expert है. Somebody could work for 2 years and be an expert. If he's worked on the right number of things and if he's smart, you measure expertise by competence, not by number of years. So what happens is, if you draw a line in the sand and say someone is an expert only when he's worked 10 years and he's worked 7 years, he doesn't find a job for the next 3 years. And that is what clients write down in their tenders when they are on the Dunning-Kruger curve on the left. They say, I will specify expertise in the number of years. So you lose talent to other regions who never come back. So you cannot actually start going and doing your projects better because you don't have talent in-house. Why did North Sea or Gulf of Mexico do so well? They had talent which was captive there. They had a vendor ecosystem which was there. So you can turn around and do projects much faster, which is something which we have to replicate in India. So. And then sustainable and clean development, right? We all know Macando, right? One incident can bring down a company. One incident, right? So the fact is that, even when you're laying a pipeline, even when you're doing something onshore, any local gets into a protest, it goes on Twitter, your entire project is in jeopardy, right? You cannot disturb the ecosystem. And it seems deep water is simple, but where do you produce? Eventually the production comes onshore, right? You have to have somewhere where you are either selling gas, unless you are doing it, purely FPSO से offloading, but uska bhi controls तो कहीं से आ रहा है. You have to have an onshore element. So the onshore element is somewhere where your entire project can go off track if your community is not being managed very well. So that is one final thing. And, I think I've been on time largely. So going and showing this is how subsea looks like. It looks very deceptive when you look at water. And all of you have worked offshore, or most of you have worked offshore. सामने पानी देख के बड़ा अच्छा लगता है. But the seabed is basically just the kind of surface we see outside covered underwater. So it's not as if the seabed is a plain football ground. There are mountains, there are valleys, there are all kinds of structures subsea for which we have to be prepared. And then you set up a colony there of subsea equipment, which our partners go and install, and the client then goes and produces from for the next 20 years. So that's all about the complexity of the deepwater project, right?